Derivative rules. So as we looked at the derivative by definition, we started to notice some things about certain functions and how they always had the same answer based on, if they were linear, quadratic, or whatnot. Well, there are rules that have been proven, obviously, that we can now use to kind of quicken up that process. And so I don't want you guys to forget what a derivative is, which is why we spent the time doing it by definition, even though it's a little bit longer. Remember, a derivative still is a limit as h approaches 0 for that tangent line, that slope of that tangent line. So now we're just going to go through and look at some rules that we can kind of, once again, make this go a little quicker. So if the function is f of x equals a constant, we know that the derivative is equal to 0, which once again makes sense because the slope of a horizontal line is 0. On the second one, if x is raised to the n power, then the derivative is the n gets moved to the front, and then you take one less than that for the exponent. So once again, take a look at that. Make sure you see that. So if it's x raised to the n, for example, x raised to the 2, then the derivative would be 2x raised to the 2 minus 1. So we'll look at plenty of examples, but that's the general idea what's going on. Number 3, c, where you have a constant in front of the, or a coefficient in front of the x raised to the n. Same thing happens. You can see exactly the same thing from the previous happens with x to the n, but the c just stays there, and then it'll get multiplied by that number in front. The fourth one, if you are adding terms together, you just take the derivative of each individual term, which will probably lead you back to these first three terms, or first three rules. And so I'm just going to give them numbers so when I relate back to them, you know what I'm talking about. On the next one here, they get a little bit more complex. If you're multiplying two functions together, you take the derivative of the first times the second function plus the first function times the derivative of the second. Rule 6 is division. So you can see that this one's written a little different in the book, but I set it up this way so that this right here, in terms of your product, is the same thing as this right here, except you are subtracting instead of adding. So this one's you're adding, this one you're subtracting, and then you also have to divide by the, not the derivative, just the function h of x squared. And then the seventh one is when you have a quantity raised to a power. And on this, you, similar to rule number 2 and 3, is that the n will get moved to the front, then you'll take the function and then subtract 1 from the exponent. But the difference here is now, because we're doing an entire function, not just one term, you then have to take the derivative of g of x as well. So you'll move the power to the front, g of x raised to the new exponent, subtracted by 1, and then the derivative of g of x itself. So let's go ahead and take a look at these rules and how we apply them. Alright, example 1a. Find the derivative using the rules. F of x equals 8. Once again, we don't have to write the limit anymore because we're going to use the rules to answer these questions. This is rule number 1. If it's a constant, the derivative or the slope is equal to 0. B, this is, and I guess I can write down which rules I'm using, if that's helpful. So this is rule number 1. On B, you got 6x squared, so this would be rule number 3. So 2 times 6, x raised to the 2 minus 1. So in these first couple examples, I'm going to write out exactly what the rule is saying so that you can see each part of it. So 2 times 6 is 12, and then x raised to the first power. On the third example, you are using rule number 3 for the 3x squared, and that would be 2 times 3x to the 2 minus 1. You will then also use rule number 1 because the constant has a derivative of 0. And then you're also using rule number 4 because it's the sum of multiple terms there. So your derivative, once it is simplified, is 6x to the first power and then plus 0, which you don't need. So So 3, 1, and 4 would be all three of those you would be using for that one example. D, same thing. You're going to be using 3, 1, and 4. It's just a polynomial. We're going to have to find the derivative of each individual term. So this one I won't show each individual part. We'll just do it together. So 3 times 5 is 15. X raised to the 3 minus 1 is 2. 2 times negative 2 is negative 4. X raised to the 2 minus 1 is 1. And then on this one, it's 1 times 7 is 7. And then 1 minus 1 is 0. And then minus 15 is your constant, which is 0. So then if I simplify this, I have 15x squared minus 4x plus x to the 0 is 1. So 7 times 1 is 7. So the derivative of that polynomial, which is a cubic, is now the derivative is a quadratic. Now how does this relate to slope to the tangent line? That's the next part that we will get into. Not in this video, but in the next one. Alright, let's continue. Let's look at 6 times the quantity 3x squared plus 2x minus 7. Now I could go ahead and use the product rule for derivatives, but I can also simplify the function before I find the derivative. So on this one, it'd be a lot easier to just distribute this 6 and deal with just the polynomial than to use the product for the derivative. So this would be 18x squared plus 12x minus, not 7, but 42. And then now, I'll find the derivative f prime of x. So 18 times 2 is 36, x to the first. 1 times 12 is 12, x to the 0, which is just 1, so that's 12. And then minus 42 has a derivative of 0. Okay. On B, we could actually do the same thing. We could distribute that out, but on this example, I do want to show you at least the product rule number 5, where you're multiplying two functions together. So let's go ahead and use rule number 5 on this one. So the rule says that we want to, and kind of go back and just look at this, rule number 5 here. We want to take the derivative of the first times the function of the second. So the derivative of the first, so we're finding this is f of x, this would be g of x, or whoops, we already have f of x, so let's do g of x and h of x. So the derivative of the first would be 3x to the second minus, and then this one, 1 times 3 is 3, x to the 0. So this is g prime of x times h of x. Okay, so this is h of x plus, go back to rule 5, take a look. Now it's the first function times the derivative of the second. So x cubed minus 3x, so that's g of x times the derivative of h of x. So that would be 7x to the 6th plus 10, the derivative of 10 is 0. So this would be h prime of x. And now we need to simplify that. So the derivative, go ahead and distribute that out. That would be 3x to the 9th minus 3x to the 7th plus 30x squared minus 30. So that's the first part, plus 7x to the 9th minus 21x to the 7th. And now combine your like terms. 10x to the 9th. Looks like we got minus 24x to the 7th plus 30x squared minus 30. Alright, so still a little bit of work, but remember, if we did this by definition, we would be plugging x plus h in wherever there's an x, and that's just the first part of it. So definitely a lot simpler than using the definition. Alright, on example 3a, we're going to look at the last rule, rule number 7, because you have something being raised to a power. So on the last rule, rule number 7, we have the derivative. So you'll take the exponent, move it to the front, so that'll be 5, times the original function. So 5 minus 1 is 4, so your exponent goes down by 1. But now you also have to take the derivative of the function g of x. So this inside here represents g of x. So this is g of x, and then this is going to be g prime of x. So 15x squared plus 8x, and then plus 0. And the only thing that I need you to simplify on this, because otherwise it would get pretty crazy to take the trinomial and raise it to the 4th power, is just to simplify what you can, combine what you can. So this 5 is being multiplied by this binomial. We can simplify that. So we'll take 5 times 15 to get 75, x to the 2nd power, and then 5 times 8 is 40x. So this binomial is now multiplied by 5x cubed plus 4x squared minus 3 raised to the 4th power. And we're not going to go any farther than that. Alright, on example 3b, we're actually going to use rule 7 again, but we have to look at it a little different because it is a radical. How do we rewrite the square root of something? Well, we can rewrite it as a power, which is to the 1/2. So now we will use rule number 7 again, which is equal to 1/2 times x squared plus 4x minus 5, and we're going to take 1/2 minus 1, which would be negative 1/2, and then times the derivative of x squared, which is 2x, the derivative of 4x is 4, and then the constant would be 0. So what does that leave us with? We can go ahead and take half of 2x plus 4 because it goes in evenly, so that would be x squared plus 4x minus 5 raised to the negative 1/2, and then x plus 2. So really the last thing that we can do here is not to have a negative exponent, so we'll move it to the denominator. And you can either rewrite it as the square root of x squared plus 4x minus 5, or you can rewrite it as that raised to the 1/2. Either way is fine. And there's your derivative of this function, square root x squared plus 4x minus 5. Alright, the last two examples here, we're going to find the derivative of the division one. So we're going to go back to rule number 6 for that. And to find the derivative, remember, this is g of x, and this is h of x. So we will first take the derivative of g of x, which is 2x minus 2 times h of x, minus, now we'll leave g of x the same, so we'll do x squared minus 2x plus 1 times the derivative of h of x. Well, the derivative of h of x is just x to the first, so that would be 1 times x to the 0. So just to kind of show you this, this would be 1, so it would be 1 times x to the 1 minus 1 plus 0, which is just 1. So that's 1 divided by h of x squared. So if we simplify that, distribute on top, that'll give us 2x squared. We got 6x minus 2x, so that's 4x minus 6. So this quantity minus x squared minus 2x plus 1. And so we can simplify that. To get 2x squared minus x squared would be x squared. 4x minus negative 2x would be plus 6x. And then negative 6 minus 1 would be negative 7. And then on the bottom you got x plus 3 squared, so we'll simplify that to x squared plus 6x plus 9. And so the derivative is x squared plus 6x minus 7 divided by x squared plus 6x plus 9. Alright, we'll look at the last example here. This looks similar to the one we had done earlier on example 1D, but the difference is we have negative exponents, but we still treat it the same way. We're still adding terms together, so we're still going to use our rule number 4 and 3, and we also use 1 with a constant at the end. So we're just going to go ahead and find the derivative. I'm going to write this out so you can see this. So you have negative 3 times 7, and then x raised to the negative 3 minus 1. So you're subtracting 1. Plus negative 1 times 2 times x raised to the negative 1 minus 1. Minus 2 times 4 times x raised to the 2 minus 1, and then plus 0 for the derivative of 2. So if we simplify this, we'll get the derivative is equal to negative 21x to the negative 4th minus 2 times x raised to the negative 2 minus 8x raised to the 1st, and then once again plus 0. So the only other thing that we really need to do is to simplify the negative exponents. So that would be negative 21 over x to the 4th, just for that term, minus 2 divided by x squared, and then the last one was a positive exponent, so it's just minus 8x. And so there's the derivative in simplified form. So those are the rules that we will use for finding derivatives. We'll still look at the definition. Once again, we don't want to forget that what a derivative is, that it is the limit as h approaches 0 of f of x plus h minus f of x divided by h, which has to do with the slope of the tangent line, and that's the next video that we'll get into.